Hi, I'm Radhakrishna Pillai from IIT Madras. As part of this MOOC course on basic construction materials, today this lecture will cover wood and wood products, and we will talk about use or applications of wood, and then we will look at the structure of the wood, how is it made, and then look at shrinkage and seasoning, like shrinkage related problem, and then how to address that. One of the method is by seasoning, and then look at the mechanical properties of wood, and then also very briefly on preservation techniques and couple of products also we will look at, and then even when we talk about those products, how the damage mechanisms etc. will also be discussed. As I have been telling, this course is made with inputs from various textbooks as we see here, and also a lot of photographs etc. from the internet. Now, use of wood, or where do we apply or use this use wood. So, it is one of the earliest construction material used by the mankind, and why we were using it, because it is easy to use and it is durable, and it is having high strength. I mean, depending on which direction you are using and what you are using it for, or what type of load is applied, in which direction it is applied, all that we will discuss in detail in the coming slides. And also it is a lightweight. So, we talked about easy to use, durable, high strength, low weight and widely available, low cost, and it also looks good because of the grains and the structure, which is, I mean, the design, grain structure and all that gives you good look also, and relatively low cost compared. I mean, depends. So, the cost is always factor depending on many other factors. So, but generally we can say it is cheaper if it is available in plenty. Now, still very widely used for building frames. You can see the picture on the top right corner here, building frame here, this is another, and then bridges also, then utility poles, like electrical lines etc. Nowadays, we are seeing more and more of this wood or timber products. I mean, we are starting to use reinforced concrete or pre-stressed concrete poles depending on the load carrying capacity required. Sometimes wood may not be sufficient to handle, and at the same time the availability of wood may not be that easy. So, we go for reinforced concrete, and also we talk about large number of such products. So, concrete is also being used nowadays. And then floors and roofs. For floor, you can see here, it is especially very good for people at home if they are old, and then the floor will not be very cold. It is good for both summer and winter conditions, like cold and hot climates. Wood seems to be a good option rather than some of the tiles or marble floors etc. You can, because there are advantages for health reasons. And then piles for the bridges or anything which is going into the water body, and then railway sleepers. This is widely used, but now again it's changing to reinforced concrete or pre-stressed concrete systems because of the load requirements or higher or better capacity requirements for the sleepers, but it has been used widely in the earlier time. Now, trees in general can be divided into two broad classes. One is hardwood and the other one is softwood. So, this I just put this for some information purpose. I mean, so you can see hardwood is generally available in tropical climate conditions. Tropical climate conditions. Generally, the leaf structure, you can see the top half of the screen and bottom half of the screen, there is a strikingly different structure, or the visual the appearance is very different of the leaves. So, in the case of hardwood, it is broad leaved and deciduous, that means they shed leaves annually. and they are generally porous in structure, and examples are teak, sal, oak, etc. that comes under the class of or category of hardwood. Then we have softwood, which are conifers and have needle or scale like evergreen leaves, okay, non-deciduous, and then non-porous also. Examples are fir, pine, cedar, etc. But now just these two classifications, you can look at what type of geographical location or climatic condition these two types of woods are present. Now, one more important thing is this name hardwood and softwood does not reflect on the mechanical hardness of the wood. Okay, this hardness of the wood has nothing to do with these terminologies of hardwood and softwood. Okay, just remember that. Then, what are the type of wood or species available in India? We generally use teak a lot mainly because it's easy to work with. If you ask a carpenter, what is the advantage of using teak wood, they will say it's easy to work. In other words, you don't need much energy to chisel or to work with to cut that wood, to work with that wood. Okay, it's easy to work with, that is if you ask the carpenter. Okay. So, also another technical reasons are it has good dimensional stability, that means it does not shrink or swell as a function of time. I mean it does not shrink or swell as much as other type of wood, and it is durable, that is why it is very, very costly also. Then density also matters. So, Padak is another type where it is medium density hardwood. Color also matters. So, you can look at this list here. I mean, this is not something to memorize, it is just for you to have a feel of what type of timber or wood are available in our country. Then and what are the properties you should look for also. Color is definitely one thing, because aesthetics is a function which we look for, and also the dimensional stability, strength, how easy it is to work with the timber, the wood, these things we should really worry about. I have been using this word timber and wood in between. If you really look at definition for this, timber is nothing but a processed wood, okay, but more or less I do not think it really matters. You can kind of use both words, but timber in general, when we say it is a processed wood. Okay. Now, other types are sal, deodar and rosewood. These are all available in various parts of our country. Okay. And now let us look at the structure of wood. So, each annual, you can see the picture on the bottom left. This is the typical cross section. If you take, if you cut a tree, you will see like rings like this. Okay. Now, these are like each ring represent 1 year. Okay, each ring in this. So, by looking at this cross section of the wood, we can tell the age of that wood, okay, or age of that tree, we can tell. Now, look carefully on the picture, you can see an early wood which are light rings and a late wood which are dark rings. Now, on the right side, bottom right side, you have a close-up image of this yellow region which I have shown in the left side image. It is a close-up view. On the right side, you have a close-up view. So, it is something like this, if I look at. So, this is the close-up view of this yellow region. Now, look at this dark and light color and the dark color rings. It is very clearly shown on the right side image. So, this region you can see early wood here, these are the light color region, and the late wood which are the dark color region. Okay. So, you can see that late wood is more dense, like this region is more dense, and early wood is less dense, this region is less dense. Okay. So, that is clear. So, two types of when you form the ring. So, now look at why this late wood and early wood. Okay. Now, early wood, it is like a rapid growth of hollow thin walled cells. This is the early wood we are talking. Okay. You can see in this region you have larger cell walls, they are hollow and they grow rapidly okay, during the spring or wet season. That is when they grow rapidly, because whichever cavities are formed, that will get filled with this moisture. So, they kind of have a, eventually they will have a larger cavities, okay, or the cell structure is like that. Now, when you talk about the late wood, which is this, you can think here, these are denser region, and these are thick walled cells. In the first early wood, they are thin walled cells. Now, these late wood are formed during the summer or dry season, and they are thick walled cells and smaller in size also. The cavities are also smaller, and hence, because they are thick walled, they are much harder and stronger than the light rings. Okay. So, this is the main thing to learn about these different rings and the region of the ring. Late wood and early wood, which one is stronger, which one is weaker in comparison, and which is formed in which time of the year. Okay, and then the reason for the the strength, because you have thick wall, the wall thickness plays a major role, and the size of the cavities also plays a major role. If I look at here, this is the cavity I am drawing on the picture here. This is the cavity, and this is the wall thickness which I am talking, or the wall. Now, structure of the wood, main structural features of a tree. If you cut a tree, okay, these are all the different parts of a stem. Okay, you can see here, the first one is the central axis of the stem. Okay, we call it pith, and then you have something called heartwood, that is here. I am just connecting the image and the text. Okay, so heartwood is the core of the wood. It's darker, and we say it is non-living, and it provides a structural support. Okay, it's not actively growing, or it's a structural provides a structural support. Then you have sapwood, which is the lighter color region here, and it transports the sap and moisture from the root and stores the food. Okay. Then you have cambium. As you go outer and outer, you have cambium here, which is a thin layer. Okay. So, you can see here, just thin layer is what we are talking, this thin layer, darker color region you can see there, that is the cambium. And what is it? Is a very thin layer between the bark and the wood. Okay, a location of wood growth, that is where the wood grows laterally. Cambium. Now, inner bark is another, bark is kind of looked at as the outer shell of the core wood, and the inner bark and outer bark. There are two categories for this, two regions for this bark. So, inner bark transport the sap from leaves to the growing part of the tree. Okay. Now, which is that growing part of the tree? That is the cambium. We just discussed that. Now, outer bark is the dense or rough layer just for protection. Okay. So, this portion here, it is just for protection. So, this is in generally what, if you take a timber or if you cut a wood, you can look at the cross section and you can see these different regions on a wood. Now, there are also another important thing which we need to look at is the direction, longitudinal direction, tangential direction, and radial direction. I will discuss this later, but just remember that the properties change as we look at timber in different directions. Okay. Now, chemical composition. What is the chemical composition? In general, wood, you can look at the graph on the bottom right. There are three key components. One is cellulose, which constitute about 40 to 50%, and then you have hemicellulose, and then you have lignin. Okay. So, the composition you can see, cellulose is the major component, and then you have about 20 to 30% hemicellulose, and then 15 to 25% lignin. Now, what are these three things? Cellulose, what is it? It is a high molecular weight linear polymer built from glucose monomer. That is in general description of what cellulose is. You can see a polymer structure here, and then polymer that forms strands, fibrils that make up cell walls fibers. These two things I will talk in the next slide. This fibrils and fibers you will see in the next slide. The same image I will show again. Now 50% by weight of wood is because of the presence of cellulose, and its specific gravity is about 1.5. So, if high density, and that leads to higher strength also. Okay. Now, lignin, you have it is basically the glue that binds the different cells together, or the cementitious property. Essentially, it is a glue. Okay, that is what it is, and it is 23 to 33% of softwood, and in case if it is a hardwood, then it is. So, these numbers, I am not expecting you to memorize these numbers, because this will vary from wood to wood, but just to have a ballpark idea about how much is the composition, etc., etc. Okay. Now, what it is lignin? A 3-dimensional phenyl propanol polymer. Okay. Anyway, so this general idea only. Now, hemicellulose, several sugars tied up in its cellular structure. So, this is how the chemical composition. Main thing is to look at which is the key component, which are the key components, and what is roughly the proportion and their role. Okay. So, most of the properties are provided by the cellulose, and lignin plays like a role of combining or binding these cells together, and hemicellulose is whether different sugars tied up in cellular structure. So, this is what the chemical composition. Now, look at the physical structure of wood. Physical structure, okay, as we will start from macro level to micro level. That means from the top left of the screen to the bottom right of the screen. So, let us see a tree. Okay. You cut a stem of a tree, and that is this like this. If you cut it like that, what you will see, let us say in the range of centimeters. Okay. A few centimeters, let us say, depending on what you are cutting, 10 centimeter, or if it is a very large tree, might be even going into meters. Anyway, whatever that is. So, you take a stem, and then you can look at these red squares or rectangles shown on each of these image here, which kind of indicate the next image which is zoomed in. So, from the first image, I have a rectangle here. So, the second image is the how that rectangle looks like, the transverse section. Okay. So, and now if I cut another here, this is showing this thing. Okay. So, like that, zooming in, you are sequentially getting more closer and closer image. Okay. Now, second is very clear. Now, third one, it is showing what are the rings which we talked about, the growth rings we talked about. Very clearly you can see the growth rings. You can see the early wood and late wood here, right. So, you can very clearly see this is the early wood and the late wood. So, just to re-emphasize that. So, you can see here the denser one are the late wood, and the lighter one are the early wood. So, here you can see this denser one is the early wood, and the denser one is the late wood, and the lighter one is the early wood. Denser, late, and lighter, early. Okay. Anyway, now if you look at this region here, you can see the close up of that cellular structure, close up of the cellular structure. Now, here you can see you have again these cell walls, etc., are visible here. Further going, so you can also track the size in which you are talking. This is like about 0.5 millimeter. Okay, so very small region we are talking about, this one. Now, if I go to the cell wall structure, I am sorry, I think in the beginning I told that we will go from top left to bottom right. No, we are going in a clockwise direction. So, going like this, and then we will go like this. Okay, sorry. So, top left to bottom left, that is how clockwise direction we are going. So, here now you can look at the cell wall structure, where you can see different again microstructure level. You can see 25 micrometer, that means 0.025 millimeter. So, you can see how small we are looking at. Okay. Then looking at one of the cell wall element. Okay. So, here this is how the cell wall element looks like, fibril matrix, how the fibrils looks like, and then you can see here these are all each of those fibrils. Okay, all these green circles here are individual fibrils. Now, next image on the left side looking at fibril. Fibril structure, you can see microfibrils and amorphous structure, crystalline structure depending on what type of tree it is, and then you can see it is also very, very small, 0.01 millimeter. Sorry, this is nanometer, right. So, it is sorry, it's you can see it is nanometer, very small. So, 10 nanometer scale you are talking about there. Then further if you go into the chemical structure, you can see cellulose. This picture I already showed in the previous slide. Okay. So, this is in general the physical structure of wood. Okay. So, you can start from how a tree looks like and all the way into the small chemical structure of the wood. Now, also when you look at the physical structure, there are something which you might have already seen on wood, there are something called knots, okay, and also there are live knots and dead knots. How do they function, or what is the role, how do they influence the properties of the wood? So, what they are essentially is they join the trunk and branch of a tree. So, if we can think here, this is where a branch is coming out of a trunk or a stem, and now if it is live or green knot, it will be something like this. Okay, that it means it is active, they are connected together, they are bonded well together. Now, if it is a dead knot like this shown on the bottom right image, okay, you can see that it is not really mechanically, it is not bonded to the wood. So, if you just try to pull it out, it will come off. Okay. Now, this has a problem, or wood or timber with this kind of knots may not always be good when you look at mechanical behavior. So, what happens is, why this is happening is the cadmium, which is the growing part of the wood, like I said, thin layer between the bark and the growing between the bark and the heartwood or the sapwood, between the sapwood and the bark. So, this thin layer of cadmium, that actually if that gets dead, then the knots also get dead, because there is no further connection between them. So, now because of that there is a lack of continuity. So, it also affects the the stress transfer, etc. And the trunk grows around the dead branch and even the bark. The dead knots may drop out of the plank on sowing, but there are also cases where you might have it inside the wood, but it is not just falling off, but it stays there. But the way you apply the loading, it might have an influence on the behavior. Okay. So, the question here is, are knots good for compression? Now, look at this picture here. If I compress this wood like this, okay, and like this, if I compress the wood like in the direction parallel to the grains, if I compress the wood in the direction parallel to the grains, okay, what will happen is there will be a lateral force generated here, lateral stress will generate here, and it like this, okay, and it can the stress concentration will happen here, and it can actually lead to failure of the wood because of the dead knot there. and also it might push out the dead knot. That is one thing. Now, if I apply a load in the other direction, let us say I am applying the load in this direction, okay, then also there is a compression and it might push the knot out, but again you might experience that there is a stress concentration, but depending on the direction it might not affect much in this direction, but in the other direction which I showed you earlier, it will definitely have some impact on opening up or cracking of the wood along the grains or between the grains. Now, properties of wood, they are anisotropic in nature. That means they are very much dependent on the direction. Okay. So, I would say even rather orthotropic in nature, but again let us say it is anisotropic is the key word which we are talking here. Now, in the longitudinal direction, that is this direction, in that is along the stem or along the grains, parallel to the growth rings, parallel to the axis of the growth rings. Okay. Now, they are strong in that direction and least shrinkage happens in that direction. Okay. So, that means look at the picture on the bottom right, you can see this is the longitudinal direction I am talking, and these are all the grains you can see on this, and along the grains they do not shrink much, okay, or shrinkage in this direction is very minimal. Shrinkage in this direction is very minimal. Now, if you look at the perpendicular direction, either radial or tangential direction, okay, either radial or tangential direction, you will have the weakest or weak, the strength is weak in that direction, and shrinkage happen mostly in these directions. Okay, shrinkage happens. So, this will shrink this way or it will shrink this way. This is what we are talking about. But the shrinkage in the longitudinal, this shrinkage is very less. Okay, here it is more, here also it is more. Okay. So, I think that is clear. So, directions influence the strength, the modulus, the thermal expansion, conductivity, shrinkage, all these mechanical properties are very much different in these three directions of a timber, okay, especially between the longitudinal and the other two directions. Now, there is something called fiber saturation point. What is that? So, this is the moisture content when cells are completely saturated with bound water, the water which is chemically bound, and but no free water inside the cavities, inside the cell cavities. So, the cell walls, okay, the cell wall, let us say this is the cell wall, okay. So, the cell walls here, let me draw it again. So, it says cell cavities, assume that this is a cell, wood cell, and these are this is the cell wall, okay. Now, the highly the water is held tightly in cell cavities, wood shrinks on removal. So, this is the bound water which you are talking, and now water inside the cavity, the second one is this one, the water inside the cavities does not affect the shrinkage, okay. So, first when you try to dry wood, what will happen is, first let us say I am going to call this region A and then region B, okay. First what will happen is the water in the region A will evaporate, that is the free water, and then after further drying, then only the water in the region B, or that is the cell wall itself, will start evaporating, okay. Now, FSP is about 20 to 30% for most of the wood. So, above the FSP, that means if the water content, if there are still water in the region A, okay, then it affects only the weight, and below FSP what happens is, below FSP means you are now start taking the water from the region B, and then the properties start getting affected, like physical and mechanical properties will start getting affected. Let me reiterate this once more. Let us say you take a new wood, you cut it, you are going to process it, and now you have to first dry that wood, right. So, initially you will have a lot of moisture in the wood. Now, as you start drying, first the water in the inside the cell cavities, that is the region A, will start drying. Okay. At that time, the only change in the wood is the change in the weight of the wood, loss of water. Now, after further drying, when you reach like fiber saturation point, at that time, then the water from the region B also start evaporating, and then the properties start changing. Not only weight, but also the shrinkage and mechanical properties starting. And now I am going to show you this thing once more. This sketch is just to tell you about the direction of shrinkage. In the longitudinal direction, we have already discussed this. In the longitudinal direction, it is negligible, and in the tangential and radial direction, there is a twice as much difference in general. Now, this is what we were just talking about, what is FSP. So, let us say I am extending this to the right, and let us say this is about 100%, okay, fully saturated wood. Now, now what happens, you have to go from the right end of the graph to the left. Okay. So, this is how we start drying the wood. No? So, up to about 20 to 30%, that is this region here, there is no change in the shrinkage property because the water from the cell cavity is being evaporated. Okay. So, this is what I drawn earlier. Okay, this is B region and this is A region. So, from water from the cell cavity is evaporated. So, after this 20 to 30%, you can further drying, you are removing water from the wall region, that is the B region, and that leads to change in the properties. So, largest shrinkage happens in the tangential direction, and then smallest shrinkage in the longitudinal direction, as we discussed earlier, and negligible shrinkage above FSP regardless in the direction. Above FSP, there is no shrinkage happening because it is just water from the cavities are being evaporated. Okay. Now, damage due to shrinkage. So, you can see here on the left image, you can see that there is a pop outs, different type of, if you have ever been to places where timber is used for flooring, etc., you will kind of see these kind of problems because of the warping, etc. So, you can see the right side picture kind of shows different type of problems which are experienced in such structures. Okay. You can see here mildew or some fungal growth, etc., because of the water droplets staying there, and then color also starts changing, fading, and then here you can see cracking, and then here you can see warping. You can see that this wood has turned like this, no, it has warped, the shape has changed. So, the center portion lifts up, and splintering you can see here. So, small grains can come out, or we call it splintering, and then UV damage is also sometimes possible. And if you have a nail, if the wood starts, you can see here slight warping in the other direction here, and then cracking here. So many of these problem, we call this behavior cupping on the right side. So, when that happens, even the nail can come off, okay, because of the pressure exerted by the wood itself, by the shrinkage action. So, these are all general problems which are experienced by wood and wood structures.